So today we're going to be looking at lesson 4-6, and it is on completing the square. So we're going to use completing the square to help solve quadratics. So it's just another method. So completing the square is a process of finding a constant c. So you're going to get rid of whatever c is not making your trinomial a perfect square trinomial, and you're going to create your own c, and you're going to add it to the first two terms so that this is a perfect square binomial. In other words, it factors to something that looks like this. So the binomial that came from that would have been x squared plus 6x plus 9. So as you can see, perfect square, perfect square. If you took the square root of x squared, that's x. Square root of 9 is 3. 3 times x times 2 is 6x, and so that meets that test of 2ab. This is just a visual representation of what x plus 3 squared really means. So you would have this side length represents x, and then each of these would represent a 1. So x, 1, 1, and 1. So then the area of a square or rectangle is length times width. So x times x is going to give you x squared. And then each of these right here have a dimension of x by 1. So x times 1 is x. So this is going to be an x. This would be an x. This would be an x. That means this one's an x because it's 1 by x, and x. So altogether, so far I have 1 x squared, 1, 2, 3, 4, 5, 6 x's. And then last but not least, all of these are 1 by 1s. So the area of each one of these is 1. And if you count them, you have 9. So here's your plus 9. Now, part of completing the square is also using what's called the square root method. So we're going to start kind of backwards so you can see where we need to get to and why we're going to have to complete the square. So here I've got x squared by itself, no x term, and the constant's over here on the right. So if we use the square root method, we're going to take the square root of both sides to solve. But don't forget that this exponent here means that we're going to have two answers for our value. So if all you did was take the square root of both sides, you would just tell me that x is equal to 3. Well, there's got to be two values. And remember that when we take the square root of this, typically I'm asking you for the principal square root, but I want any value when squared, and you take the square root of it gives you, or I'm sorry, any value when you square it gives you 9. Well, that could be positive 3 or negative 3. So there are two values squared that give us 9, so we have to put in here a plus minus in front of the right side that we're squaring, the side other than the squared term. And so we end up getting x equals positive or negative 3. So the other way to look at this is, well, what if we had used our factoring method that we did before this? I would have subtracted 9 from both sides to move it towards the x squared, and you would have had x squared minus 9 is equal to 0. Then to factor this, it's the difference of two perfect squares, so it factors with the plus minus pattern. The square root of x squared is x, and the square root of 9 is 3. And so then you would have set x plus 3 equal to 0, and x minus 3 equal to 0. And then to solve for x, you would have had negative 3 and positive 3. So both of these should give you the same answer, and they do. But you can't always factor like this to get an answer. There are some quadratics that are not factorable, they're prime. And so we're going to use completing the square to fix that. But before we get there, solve by finding square roots. So these are your, I'm still losing my voice, so I apologize. These are the steps you're going to use to solve. So you've got to isolate the squared term. So notice how the squared term was isolated. Once it's isolated, take the square root of both sides, and then remember that every non-zero number has 2 square roots, so you have to use that plus minus symbol, and then simplify completely. So, highlight. And then other things that are important in here would be isolate the squared term, take the square root of both sides, and then don't forget it has 2 square roots, so use that plus minus symbol. So I'm going to make this bigger, and we're going to look at the first example. So here's my squared term. I have no x term, so if I'm going to use the square root method, I need to isolate this x squared. So I'm going to start by subtracting 9 from both sides. I get 2x squared is equal to 4. And then I'm going to divide both sides by 2. And I get x squared is equal to 2. Then I'm going to take the square root of both sides and plus or minus the square root of the right. Square root of x squared is x. I cannot take the square root of 2 or simplify it further, so my answer is just plus or minus 2. That's it. So you try number 2 on your own, so pause the video and try this on your own. Okay, so hopefully you did try this on your own, so we're going to add 10. So we get 7x squared is equal to 45. When you divide by 7, however, it's not as nice as number 1. 7 doesn't divide in there evenly. And you cannot divide 45 and 7 by the same number, so it's just 45 sevenths. So when you go to take the square root of both sides and you do plus or minus the square root here, remember you can't have a fraction under the radical because that leaves radical in the denominator. So we end up with x equals plus or minus, I'm going to split the 45 and the 7 into 2 different radicals, and I'm going to prime factor 45. Well, 45 prime factored is 5 times 9, which is a 5 and 2 3s, divided by the square root of 7. Well, we need to rationalize the denominator, so I got to multiply radical 7 by radical 7 to make that radical go away. What I do to the bottom, I have to do to the top. And in addition to that, I'm going to take a pair of 3s out in front, right here. That's a lovely arrow. I know, there, that's much better. All right, so x equals plus or minus 3 radical. I have left underneath the radical a 5 and a 7. So 5 times 7 is 35, all over radical 7 times radical 7 is just the number under the radical, 7. Then if the 3 and the 7 could reduce, because they're both outside, you would. They can't, so this is your final answer. So let's solve when we have a perfect square trinomial, because this is where we're hoping to be when we complete the square. Mind you, we have not completed the square yet, but this is going to kind of show you where we're trying to get with completing the square. All right, so if you look at the left, I know that we have a constant here and a constant there. Don't try to move this over here, because right now I see a perfect square and a perfect square. This could be a perfect square trinomial, but you got to test it. So remember, the test is 2 times a times b. And so I'm going to multiply to get a and b. I take the square root of x squared, which is x, and the square root of 49, which is 7. So 2, that's a times, 2 times x times 7 is equal to 14x. Again, don't worry about the sign, but it matches. As soon as it matches, you know that it factors into the squared binomial. And if you recall, so remember that each of these terms is going to contribute something into this factoring. So each of these square roots are going to go here. So the x and the 7 is going to go here. So x and 7. And then the sign of the middle term goes here. So we're going to put a minus in the middle. And then equals the right side, which is 25. So now you have a perfect square on the left and some number on the right, which also happens to be a perfect square, but it doesn't have to be. And this perfect square, this something squared, is isolated. There's nothing in front, nothing underneath, nothing being added or subtracted to it. So we can go ahead and take the square root of both sides. It's a little bit more complicated than the previous one, but it's still doable. Plus or minus the square root of 25. So on the left, the square root of this, remember we're going to take that index and divide it into that 2. That leaves us a 1. So we get one of these. So we have an x minus 7, and that was the whole purpose of having this nice perfect square trinomial on the left, because it creates this perfect square. And then plus or minus 5, because that's the square root of 25. Then we need to solve for x, so we're going to add 7, but add 7 in front of the plus or minus. So you get x is equal to 7 plus or minus 5. Well, because you can actually figure out what 7 plus 5 is and 7 minus 5, you need to actually do so. So 7 plus 5 is 12, 7 minus 5 is 2. So those are your two solutions to the above equation. So let's look at B, and then I'll let you do C on your own. So with B, I'm going to do this one more time. I see a perfect square and a perfect square, so we're going to test it. That test is 2AB. And so to find A, I'm going to take the square root of x squared, which is x, and the square root of b squared, which is 5. 2 times x times 5 is 10x, which of course matches. So immediately you know that it factors into the squared binomial. So the square roots of these, x and 5, is going to go here. And then the sign of the middle term goes here, which is plus. And then equals 100. Now that you have a perfect square isolated on the left, you can take the square root of this side and then plus or minus the square root of the right side. You get x plus 5 equals plus or minus 10. Subtract 5 in front of the plus minus, and you get x is equal to negative 5 plus or minus 10. Then actually perform that math. Negative 5 plus 10 is positive 5. Negative 5 minus 10 is negative 15. Remember that these solutions that we're coming up with are where the parabola, which is the graph of a quadratic, crosses the x-axis. So I know that my parabola crosses the x-axis at 5 and negative 5. I also know that this parabola opens up. So that means that the vertex would have to be below. So if I had to do a quick sketch, so I would have a point here and a point here. Halfway in between would be negative 10. So right here. So I know that my axis of symmetry, or negative 5 I meant, not negative 10. So that's where my axis of symmetry would be. And because my parabola opens up, my vertex would have to be, whoops, I kind of missed it, but you get the idea. I missed the root. So this was supposed to go through here. And I don't know where exactly this vertex is unless I actually find it. But for a sketch, it's no big deal. But I know it opens up because the coefficient here is positive. I know that these are my roots or my zeros, and so the vertex would have to be below here. So pause the video. I want you to figure out C on your own. You do get an interesting answer, so do your best to figure it out and then restart the video. Okay, so if we test this, because I see a perfect square bookends, if I take the square root of 4x squared, I get 2x, and the square root of 9 is 3. 2 times 2 is 4, times 3 is 12, times x is 12x, which matches. So I know that it's squared binomial equals the 49. Inside, I get a 2x and a 3. The middle sign is negative, so the middle sign in here is negative. Then I can take the square root of both sides and plus or minus the square root on the right. So I get 2x minus 3 on the left and plus or minus 7 on the right. Then I need to make sure that I have to add 3 before I can divide by 2. So I'm going to add 3 here and add 3 in front of that plus minus. So I get 2x is equal to 3 plus or minus 7. Then I'm going to divide by 2 and divide all of this by 2. And then I get x equals. So let's do the math. 3 plus 7 is 10, divided by 2 is 5. So there's one solution. Then 3 minus 7 is negative 4, divided by 2 is negative 2. So there are your two solutions. So let's look at actually completing the square. So we're now going to complete the square so that we create here this perfect square trinomial. So no matter what's here, we're going to get rid of it and put it over on this side and create our own C. So let's see how that's done. Okay, so to create a perfect square trinomial, we are going to essentially take, you're going to have an x squared term of some sort, then you're going to have an x term of some sort, but then we're going to add to that this new c. So to find c, you're going to take b divided by 2 and square it. b divided by 2 and square it, and then you're going to add that to both sides. So this is the old c. The old c is going to be over here because you're going to move whatever this c is here, you're going to move it over to the right, and you're going to put a blank here and a blank here. And whenever you add your new c that's a perfect square, you have to add that to both sides. So how does this look and how does it work? Well, for the first 4 here, your job is just to complete the square. So that's all we're going to do. We are going to come up with some value for c that's going to make x squared plus 6x plus something a perfect square. So to do that, our new c is going to be b divided by 2, the whole thing squared. So the more times you write it, the more likely you are to learn it. So in this case, our b is it's always the coefficient of the squared term. So in this case, it's going to be 6. If you're missing the x term, then it's going to be 0. So in this case, it's 6. 6 divided by 2 is 3. 3 squared is 9. So then that means that 9 will complete that square. And that's it. If we were to factor this, which they didn't ask for, but if you were to factor it, you would take the square root of x squared, which is x, the square root of 9, which is 3, and the middle term, which is positive. So we've just created a perfect square. There is no need to test these because you're making it so. If you follow the b divided by 2 and square it, it will make a beautiful perfect square. So then I want you to try B, C, and D on your own. Pause the video and do your best. D is definitely an interesting answer. All right, go. Okay, so here, I'm going to add my blank, and then my C is b over 2 squared And then my b is 14. Now I know it says negative 14. I don't usually pay attention to signs when I do this, because when I square a negative, I'm going to get a positive. When I square a positive, I'm going to get a positive. So in this case, 14 divided by 2 is 7. 7 squared is 49. So on the blank is 49. If you were to factor this, the factoring would look like this. Then for C, so my C is b over 2 squared. My b is 24. 24 divided by 2 is 12. 12 squared is 144. And then if you were to factor this, you would have m minus 12. Now D is interesting because when I go to find C, when I take 5 and divide it by 2, you're going to get a fraction, so that's okay. Don't turn it into a decimal. Just square it. So the 5 squared is 25, and the 2 squared is 4. It does not reduce. Don't turn it into a decimal. Don't turn it into a mixed number. Leave it improper, fully reduced, and that's it. So then if you were going to factor this, it would be D plus the square root of 25 fourths, which is 5 over 2 squared. All right, so let's look at actually solving an equation by completing the square. So here are your steps. So these are the following steps that you should use to complete the square. So if you get lost, go back and make sure that you've done all these steps. So the first step is to divide each term by the leading coefficient if it's greater than 1. So in other words, we cannot have a coefficient in front of the x squared term other than 1. If there is one, like a 4, a 3, a negative 5, you have to divide every single term in the equation by whatever that coefficient is, because we have to start with an x squared. Sometimes this leads to fractions, and I generally wouldn't complete the square if it led to a fraction, but you might run into that in your homework. Then you're going to use the addition property to move the constant to the other side of the equation so that you can create your own C. So then step 3, using the coefficient on the linear term, that's big words for saying use B. So this is code for B. So they're just saying take B and take half of it and square it. So that's going to get you your new C. Then you have to add that to both sides. So you have to add that to both sides. Then you're going to factor the trinomial in this form, squared binomial. Take the square root of both sides. Don't forget to do plus or minus on the right. Solve your equation and simplify any radical or expression completely. So here we go. Let's let the fun begin. All right, so if we were to solve this, now there are factors of 7 that add to give you 12. Well, no, there are not factors of 7 that add to give you 12. 1 and 7 is 8. So this is not even a factorable quadratic. And it is not a perfect square trinomial because 7 is not a perfect square. So what we're going to do is take this 7 and move it to the other side algebraically by subtracting it. So if I subtract 7 from both sides, I get x squared minus 12x. I'm going to put a plus blank here equals, and remember I subtracted 7 from both sides, and I'm going to put a plus blank on that side. So these blanks are important because when I find C, whatever I add to the left, I have to add the same thing to the right. So let's now find C. All right, so my B right now is 12. So 12 divided by 2 is 6. 6 squared is 36. So I'm putting a 36 here and a 36 there. So what I have done is create this perfect square trinomial here, which should factor into a squared binomial. So again, I don't have to test it because I created it. So it should factor as the square root of these go here. So the square root of x squared is x. Square root of 36 is 6. And the middle sign is negative. So the middle sign in my binomial is negative. Then I'm going to bring down negative 7 plus 36, which is a 29. Now we have a perfect square on the left, and I can take the square root of this side and then plus or minus the square root of the right. So on the left, I get x minus 6 equals, I cannot simplify the square root of 29, so I have plus or minus the square root of 29. Then I'm going to add 6 in front of the plus minus on both sides, so I get x equals 6 plus or minus the square root of 29. And that's as far as I can go. Beautiful and done. So now we've taken a quadratic that was not factorable, it was prime, and we have come up with our two solutions using completing the square. So then I would like you to do try example, well, you won't be able to do example 2 yet. Is there a B on this one? Nope. Then why would they put an A on there? Good question. All right, so let's look at example 6. What if you have a coefficient in front of the squared term? What are you going to do? Well, in this case, you're going to have to divide everything by 2. So whatever that coefficient is, in this case it's 2, we're going to divide it out so that we end up with a 1. But if I divide one term by 2, I have to divide every term by 2. And so I end up with x squared plus x minus 9 halves equals 0. Well, this clearly is not a perfect square, so we need to move it to the right. We're going to add it to move it to the right, and we're going to put in our plus blanks. So x squared plus x plus blank is equal to 9 over 2 plus blank. Now we're going to create our c. C is equal to b over 2 squared. Our b, the coefficient of the x term, is 1. So 1 squared is 1, 2 squared is 4. So we're putting a 1/4 on each blank. So that means that the left factors as a squared binomial. The square root of x squared is x. And the square root of 1/4 is 1/2 because the square root of 1 is 1, the square root of 4 is 2. The middle sign of the middle term is plus, so the middle sign here is a plus. And then equals. Then we get the fun of the other side. So we cannot add fractions unless they have like denominators. So the greatest or the least common multiple between these two, or the least common denominator, would be 4. So this already has it. I just need to multiply the 2 by 2 to get 4 and also the 9. So times 2 times 2. So this gives me 18 plus 1 is 19 all over 4. So now when I take the square root of both sides and plus or minus the square root here, on the left I get x plus 1/2 equals, and on the right I get plus or minus the square root of 19. I cannot find, but it's going to be over the square root of 4, which is 2. So this is nice that this was a perfect square, because otherwise I'd have to rationalize it, so I don't. And then I'm going to add, or I'm sorry, I'm going to subtract this 1/2 from here and subtract it from the front here. So we end up with x equaling negative 1/2 plus or minus the square root of 19 over 2. So you can leave this as one of your answers, or because these both are over 2, I can just combine the numerator. So your other answer would look like this. Bring the negative up to the top, so negative 1 plus or minus the square root of 19. Since they're both over 2, you can just write the whole thing over 2. So this is the way I prefer to write it, but either way is acceptable. All right, so let's look at example 3. Okay, so let's look at example 7. Making this much bigger. Okay. So for example 7, it's going to have a whole bunch of fractions in it, but you can deal with fractions. But the first thing that I notice is we have a 4 here. So when I divide everything by 4, and this is a perfect example of one I wouldn't use completing the square, but I want to show you that you could still complete the square even though it's going to be a smidgy bit ugly. So we're going to start by dividing everything by 4 so that x squared has a coefficient of 1. So then we're left with x squared plus 10/4 reduces to 5/2 x minus 3/4 is equal to 0. Well, this clearly is not a perfect square, so I want to move it to the right by adding it, and I'm going to put in my plus blanks. So x squared plus 5/2 x plus a blank, whoops, I don't want my blank that high, plus a blank equals, if I add 3/4 to both sides, it disappears on the left and appears on the right as a positive, and then plus blank. So now find your new c. So we've got b over 2 squared. But in this case, my b is 5/2, it's a fraction. So anytime I'd end up having 5/2 here divided by 2. So we don't like to have a fraction of fractions. So dividing by 2 is the same as multiplying by a half. So I would prefer to take my 5/2, let me change that into red so I color code it correctly. So I'm going to take my b, which is 5/2, but instead of dividing by 2, I'm going to multiply by a half because it's the same thing. And so I end up getting 5 over 4 squared, which is 25 over 16. So that is what I'm adding to both sides. And so now I can factor the left. So the square root of x squared is x. The middle term is a sign of positive, so does the middle of my binomial. Then the square root of 25/16 is 5/4 squared equals. Now we get the joy of adding these together. So I can multiply 4 by 4 to get to 16, so that's my least common denominator. So I'm going to multiply this by 4 and this by 4. So 3 times 4 is 12. 12 plus 25 is 37 over the 16. So I get 37 over 16. Then we can take the square root of both sides and plus or minus the square root of this side. So the left I get x plus 5/4 is equal to plus or minus. I cannot take the square root of 37, but the square root of 16 is 4. So then I'm going to subtract 5/4 here and subtract it in front of the plus minus. So I get x equals negative 5/4 plus or minus the square root of 37 over 4. So this is one way that you could write your solution. But remember that there is another way that we could write our solution. And that other way, or, would be, since they both have the same denominator, you can just combine their numerator. So it looks like this. Negative 5 plus or minus the square root of 37. Since they're both over 4, the whole thing is over 4. I like this one better. Okay, example 8. What is y equals x squared minus 6x plus 3 in vertex form? So we could use complete the square to put this standard form into vertex form, but why? Remember previously I taught you that all you need is a and the vertex. So why not, I mean, our a here is 1. So I already have a, it's not going to be that hard to find the vertex. I don't see the point in making a problem more difficult. just for the sake of completing the square. So your first step is going to be, we're going to use A is equal to 1. And then our second step is to find the vertex. Okay, so to find the vertex, remember that is the opposite of B, so the x value of the vertex is equal to the opposite of B over 2A. So B up above is -6, and A we already stated was 1. So we end up with positive 6 over 2, which is 3. Then our y value of the vertex, we're just going to plug the 3 in anywhere that we see an x. Okay, so then we get 9 minus 18 plus 3, which is equal to -6. So our vertex is equal to 3 comma -6, and what this gives us is our h and our k. So that step 3, we're just going to use the vertex form because that's what form we want it in. So we're going to use y equals a times x minus h squared plus k. So we're going to put in 1 here for a, the opposite of 3 in here for the opposite of h, so h is 3, so we're going to put in a -3, and then the same as what we see here for k, and that's no different than we did previously. So I have y equals, so I'm going to put in 1 for a, h is +3, so we're doing the opposite, which is -3, k is -6, we're going to do the same. So then our final answer is y equals x minus 3 squared minus 6. And that's your solution. Then finally, let's do a little bitty word problem. Make it even smaller. There we go. So this one says, the lengths of the sides of a rectangular window have the ratio of 1.6 to 1. The area of the window is 2,822.4 inches squared. What are the window dimensions? So we'll use our 4-step plan. Remember that a picture is worth 1,000 words. So I'm going to make a picture of a rectangular window, and it has a length and a width. Now it says that the sides of a rectangular window have the ratio of 1.6 to 1. So 1.6 to 1. Well, if I multiply, because length times width is area, and they gave me the area, if I multiply this times this, I get 1.6. That doesn't equal that one. And if we're in this ratio, then I have to keep adding 1.6 to this side and 1 to this side to keep it in the same ratio. And so then the next one, if I added 1.6 to this, would be 3.2 times 2. Still way off from this. So instead of having to guess and check, guess and check, guess and check, every time I'm adding the same multiple of 1.6 and the same multiple of 1. So if they tell you that you have a ratio, you just need to attach a variable onto that. So then our area formula, which is length times width, becomes, we're going to replace 2,822.4 for area equals, and then our length times our width is going to be in x times our 1.6 x. So, and I'm going to flip this. So we end up with 1.6 x squared is equal to 22.4. Now you go ahead and solve that for x. So pause the video and solve it and answer the question. Okay, so from here, we are going to divide by 1.6 because we want to isolate the squared term. So I've got x squared is equal to 1,764. Then when you take the square root of both sides, now this time I don't need to do plus or minus over here because x is going to be dealing with a multiple for a side length, and we don't want our side length to be negative. That's not realistic. So we are going to ignore the negative value that we should get here because we'd throw it out anyway. So the square root of x squared is x. The square root of 1764 is exactly 42. And then this is in inches. So, therefore, the dimensions of the window are 42 inches by, and then 1.6 times 42 is 67.2 inches. And that's it. So have fun with your homework. Ask me questions if you get stuck. Good luck.